Hi, kids.
We are going to do a little torque equilibrium problem. You ready? So have you ever seen those window washers up on the skyscraper? Yeah, we're going to do a problem like that. So I have an 80 kilogram window washer standing on a 3-meter long board. The board is 10 kilograms. He's standing 1 meter from the edge. And we want to determine the tension in each of the strings supporting him, on the side of the skyscraper. So what are we going to do first? We are going to draw a picture represent our problem. So let's do that. So you ready? So let's draw a picture that's going to represent the problem. So here is the board. The board is 3 meters long. You have your window washer. It doesn't really matter which side they're standing on, but we'll say our window washer is standing on this side of the board. He is 80 kilograms, where that distance right here is 1 meter. And then I have a string here and a string right there. So this is a picture that's going to represent the problem. So then, all right, so what do we have to do? We have to draw an FBD. So let's draw our FBD. So remember, with torque and rotation, you need to draw like an extended FBD. Why? Because where the force is being applied is important. So here is my board. Okay, let's hope the board stays in equilibrium, because otherwise our window washer is in deep, trouble. And we're going to draw our forces. So, all right, so let's draw our forces. We have the force of tension. I'll call it force of tension 1. On that side, we're going to have force of tension 2. Right in the middle, you are going to have, from the center of mass of the board, you're going to have the force of gravity from the board, and then our window washer, force of the window washer is going to be pointing down right there. Okay? So there is our FBD. And then what do you do after that? Well, you use your FBD to write your equation. So if I use my FBD to write my equation, let's write the force equation first, because the force equation is going to be easy. Hey, all the force is one way minus all the force the other way. So I'm going to say FT1 plus FT2 minus FG minus force from the window washer. Hey, that has to equal 0. Why? Because our board is in equilibrium. And then if you plug stuff in, it's like, hey, I don't know how big this is. Shoot, I don't know how big that is. This, I know, is going to be, FG is going to be 10 times 9.8. And then this would be 80 times 9.8. And that equals 0. Shoot, I don't have enough stuff. I can't solve yet. But that's where now you have to write your torque equation. So let's write our torque equation. So remember, when we're writing our torque equation, the formula for torque is the lever arm times the force, and these two things have to be perpendicular to one another. So if we're doing this, you need to look at your picture and go, what should I call my axis of rotation? Remember, if it's in equilibrium, you can pick any place you want. I could pick the center if I wanted. I could pick this force if I wanted. I could pick here if I wanted. I could pick any place that I want, and I could solve the problem. But if that's the case, if you can pick any place you want, let's pick a point that is easy. So a point that's going to make it easier for us is, hey, I don't know how big this force is or this force. So let's pick the axis of rotation where one of those unknown forces are. So it doesn't really matter. We'll say this, okay? So I'm going to put an X right there. This is going to represent my axis of rotation. And then what you're going to do is you're going to take your pencil. So take your pencil. You're going to put your pencil right on your board, right on your piece of paper, and then you're going to go, all right, which way are these different forces going to cause it to rotate? So first of all, this force is not going to exert a torque because, hey, look, if I push that way, it doesn't cause it to rotate. There's no lever arm, it's not going to rotate. If you look, this force clockwise, this force clockwise, this force counterclockwise. So you write your equation, okay? So it's all the forces, causing it to rotate one way minus all the forces causing it to rotate the other way. So in this case, it would be RG, which would be, hopefully that makes sense, that would be RG times the force of gravity plus, because again, this plus this, for the lever arm for the washer times the force of the washer minus the lever arm for T1 times the force of T1, and that has to equal 0. Okay? Everybody okay with my equation? And then you can plug your stuff in. This, because this whole board is 3, this would be 1.5 times 10 times 9.8. Okay, plus, hey, this one for where I am, that would be 2 times 80 times 9.8 minus, hey, the whole lever arm would be 3 times FT1 equals 0. And then you just got to do the math. So I'm going to do the math. If you want to pause the video, you can, but and do the math also. So 1.5 times 10 times 9.8. This is 147. 2 times 80 times 9.8. This is 1568. And then, so if I add those two together, plus 147, I get 3T1 equals 1715 divided by 3, and force of tension 1 equals 571.7 newtons, and it is going to point up. Hopefully you guys can see that. Yes, you can. Perfect. So then you're going to come over here and you're going to plug it in. 571.7 plus FT2 minus 98 minus 80 times 90, 9.8, 784 equals 0. FT2 equals, and if you add all of this up, so this plus 98 minus 0.7, you get 310.3 newtons pointing up, and hopefully this is FT2. So hopefully it makes sense. Hey, look, the tension here is going to be less than the tension here. Why? Because there's more force on that side. There you go.
Bark it!